All right, take 3. Call this the Cliff Notes version. 87 TD, om606 from 199, 300D, stock turbo, air-to-air intercooler in place. Coming down here, and you can kind of see it going in here, coming through. There it is back there, and coming over here and going back up to the stock manifold and into the motor. All right, mechanical pump, 6mm elements, maybe a little more than the motor ran stock, but not a whole lot. Drives nice. Have a plan to upgrade the pump, put more fuel through the motor. Therefore, needed to figure out how to get enough air in there to burn the fuel. Got a compound turbo setup. My atmospheric turbo is a little smaller than I would like, so in order to get sufficient pounds per minute, I need to dial up the boost a little more than I would like. It would run okay as a single, but it wouldn't boost very well. So it wouldn't spool very well. So I have a compound setup, and now I have to figure out how to intercool it at high boost. So the higher your boost, the more heat you have to reject. Most people put a big air-to-air right here. I like my air conditioner. I'm going to keep it. So I'm not putting an air-to-air there. I'm not cutting out my bumper. So that means that this area down here is what I have for heat dissipation. And get into like airplanes here where we're talking about cooling drag and that kind of thing. And so who thinks about cooling drag? Well, electric car guys actually, in particular Tesla, have thought a lot about it because they're trying to eke every bit of mileage they can. In fact, the new Tesla Model 3 I don't even think has a battery cooling heat exchanger on the front of the car. It has only, I believe it has the AC system with heat exchangers on the AC system cooling loop going into the battery cooler. But Model S was not that advanced. This is what it uses. This is a, I forgot where I got this thing. But anyway, you can get them. And the reason I chose this is because of restricted frontal area and restricted space up here. That's probably one of the only really good reasons to go with the added complexity of a water-to-air intercooler. Because the, as you can see here, the tubes between the fin rows are actually about as high as the fins themselves. You only get 8 rows of fins there, and the fins are the available heat dissipation area for creating heat rejection from the frontal airflow of the car. So because the fin area is reduced, you get limited heat rejection in this type of an intercooler, and you need a big surface area to compensate for all that surface area that's taken up by the tubes running across. All right, so why is water to air better? Well, you can see very clearly that the tubes between the fins are tiny, right? So you have fluid running down these little tiny lines between the fins, and the heat capacity of water is about 100,000 times that of air. So these tubes can be truly tiny, you can have a frontal area of your cooler that's almost entirely fins. Now, the other thing about this intercooler is that it's thick. You can see that it's about 2 inches thick. Here's the part number if anybody's interested. It's probably a stock cooler off a 98 or 99 E300D. As the air progresses through from the front to the back of the cooler, it starts to heat up. So by the time it gets to the back of a 2-inch cooler, it's already heated. In the back half of the cooler, all that area back there, because it's behind the front half, doesn't cool as effectively. So it's not as efficient. Well, so what do you want? You want a big frontal area, and you want low thickness. This is 9/16 of an inch thick. It's also actually, I don't know if you can tell, but that's actually subtly curved. I've been looking all over for units that were actually pre-curved. This is one of the few that I've found. I think because you get that thickness down, the stiffness, inherent stiffness of the material is limited. I could probably roll that a little bit and probably get it to curve even more if I wanted. So we'll see how it goes in there. But I thought I'd run through some rudimentary math just to kind of prove the point. All this is like totally, obviously, not installed on the car. Can't quote any results, but if you go through the stock cooler, 22 inches wide, it has 6 bends per inch on the fin material. It's 2 inches thick. Each bend has, a down and an up to it, so you get actually 2 fins per bend. There are 8 rows of those 22-inch, 8 rows of 22-inch wide fins, and each row is right. So you get the idea. There are 8 rows of fins from top to bottom. The actual height of each fin is about 5/16 of an inch. So when you multiply 22 inches times a down and an up times 8 rows times 5/16 times 2 inches thick times 6 fins in a linear inch width-wise, you get 1,320 square inches of fin area on the stock W210 intercooler. Basically the planform or frontal area of that intercooler is, as I mentioned previously, it's about 22 inches on the core, and it's about only about 4 inches high, so it's 22 by 4 plus the end tanks. All right, moving over to Tesla, we get 26 rows of fins. There are 12 bends per inch, and there's 2 fins per bend. The core itself is 33.5, not including the end tanks, inches wide. The radiator is 9/16 of an inch thick. It's 0.5625 inches thick. And in the fin height, each fin row is 1/4 of an inch high. So basically what we have here is this number, whatever it turns out to be, 2,900 and, let's just say, 2,940 square inches versus 1,320 on the stock. So this is the surface area of the fin that's available for rejection of heat to the air in the stock Tesla Model S cooler. This is the early model. They made a late one too. I believe the dimensions are similar, but I think the actual flow attachments are different. I should probably pick that up and show you. I mean, there's an attachment. It looks like a standard 3/4 inch attachment. I can't remember what the decimal equivalent. Comes with nice little rubber mounting feet. So figure out a way to, weld a bracket in there, and I believe this is probably a drain plug. And no cooling tank, and there's even a T on it. I think they're having these made by some outfit out of Germany. I found that. You can look them up by the part number, which, if anybody wants to know, is there, the 600-7372-00.A. All right, I'll let you know how it works in another video. That's it for now. Bye.